Good morning students. Today we are going to start a chemistry lesson, that is air. So first we will see small introduction about that. So air is the mixture of gases that is surrounding our planet earth, and that is essential for our survival of for all the living things. So it is essential for living things. So in the air that is containing 78.09 percentage of nitrogen. So 78.09 percentage of nitrogen and 20.95 percentage of oxygen, and then 0.93 percentage of argon and 0.004 percentage of carbon dioxide. So these are the percentages that is present in the and the small amount of the gases, and some of the small percentage of the gases also present in our environment. So how we are breathing? We are breathing in a oxygen and breathe out the carbon dioxide. So plants in turn they use of carbon dioxide for the photosynthesis, and they will be releasing the oxygen into the atmosphere. So that only we are breathing and breathing out the carbon dioxide. So we are nowadays we are cutting more trees. Yes or no? We are cutting more trees and we are going to miss our carbon oxygen, and we'll be suffering that. So we should not cut our trees and we should grow more trees. So first in this this is a small introduction about the air. So first we will see about the oxygen. So all the living things that in the world need oxygen, yes or no? So every one of the things which is in our world need oxygen. So without that we cannot imagine. So who is the first person? Means Swedish chemist, that is C.W. Skeely, first discovered the oxygen in the year 1772, and he called the gas the fire, air, or oxygen. He is called as the fire, air, otherwise vital life, because it was found to support the process of the burning. So without oxygen we cannot burn also. So that was independently discovered by the British scientist, that is Joseph Priestley, in the year 1774. And who is the father of our chemistry? Means Lavoisier. Lavoisier is a father of our chemistry, and the Lavoisier only named as the oxygen. So the name oxygen that is come from the Greek word oxygenes, which means acid producer. Oxygen means acid producer. So that is called. So it is called so because early chemists thought that oxygen is necessary for producing the all acids. Oxygen is necessary for all producing acids. So this is about the oxygen. So next we can see the occurrence of oxygen. So the oxygen is the most abundant element on the earth by the mass, and the third most abundant element, that is after the hydrogen and the helium in the universe. So it occurs in the free state as a free state and the combined state also. So that is the oxygen is present in the free state as the diatomic molecule in the atmosphere, in which the chlorophyll that is present in the leaves of plants that uses the solar energy to produce the glucose. What is the equation? Means 6CO2. So that is 6 carbon dioxide plus 6 H2O, that gives the energy from the sun. So that only produces the glucose. So what is the formula for the glucose? Means C6H12O6. So this is the formula for the glucose, plus 6O2. So this is the equation. Then in the combined state it is present in the earth's crust and as silicates and metal oxide. So the oxygen also found in the water on the surface of the earth. And the triatomic molecule. So triatomic molecule is a O3, and that is also known as ozone. O3 is known as the ozone, and that present in the upper layer of the atmosphere. So oxygen in the free state and the combined state. Next is we can see. So here sources and percentage. Atmospheric air, what is the percentage in the free state? Means that is a 21%, water 88 to 90% when the oxygen is in the free state. So when the oxygen is in the combined state, what are the sources and percentage? Plants and animals, they will be having a 60 to 70%, and minerals in the form of silicates, carbonates and oxides. So that will be having the 45 to 50 percentage. So this is the oxygen in the free state and then a combined state. So next we can see the physical properties of oxygen. So what are the physical properties means oxygen is a colorless, odorless and the tasteless. They will be oxygen is a colorless, odorless and tasteless, and it is a poor conductor of heat and electricity, and the oxygen dissolves readily in the cold water. So it dissolves in the cold water, and comparing to everything, it is denser than air, and it can be made the liquid at high pressure and the low pressure, and it supports combustion. So next we can see the chemical properties of oxygen. So what are the chemical properties means combustibility, reaction with metals, reaction with non-metals, reaction with hydrocarbons, rusting. So first we can see the combustibility. So that oxygen is a non-combustible gas as it does not burn on its own, but it supports the combustion of the substance. So oxygen that it will not burn by own. So it if you are burning any substance, in that place the oxygen will be present. It is the oxygen is only the supporting for a burning. So next we can see the reaction with metals. So reaction with metals, the oxygen is reacting with metals like sodium, potassium, magnesium, aluminium, iron, etc. So these are some of the metals that is reacting with the oxygen. For example, metal, we can take a sodium. So sodium is a metal and oxygen. So metal plus oxygen, that will be giving a metal oxide. So here we have taken as a sodium, that is formula from the symbol of the sodium is Na. So 4Na plus O2 gives the 2Na2O2. We are getting a sodium oxide. So this is the reaction with metals, and some of the reactivity of oxygen with metals we can see in the tabular column. So at the room temperature, potassium oxide, that is a K2O, metal, that is a metal, potassium. So Mg, that is a magnesium, in the temperature of heating slightly, so that we'll be getting the product as a magnesium oxide. The metal calcium, heating slightly, then what the product will be getting, calcium oxide, that is CaO. So FeCu, then iron, copper, then silver. So in this how the temperature will be means at the high temperature, that is iron oxide, that is Fe3O4, cupric oxide CuO, Ag silver oxide Ag2O, AuPt, that even at the high temperature, and there will be no action in that. So next we can see the reaction with non-metals. So oxygen that is reacting with various non-metals, what are the elements means hydrogen, nitrogen, carbon, sulfur, phosphorus and some of the non-metals. So these are the some of the non-metals. When it is reacting with that, how it will be means non-metal plus oxygen, that gives the non-metallic oxide. For example, carbon plus oxygen gives the carbon dioxide. So this is the reaction with the non-metals, and some of the non-metal and what are the products formed. So carbon C, that is a carbon dioxide, N nitric oxide, that is NO, sulfur, S means sulfur dioxide, SO2, P phosphorus, and it may be a phosphorus trioxide or pentoxide. So these are the reaction with non-metals. So next reaction with hydrocarbons. So hydrocarbon, that is a compound that is containing the C and H, that is carbon and hydrogen. So that it will be reacting with oxygen to form the carbon dioxide and the water vapor. For example, wood, petrol, diesel, LPG, etc. So when it is burning with the oxygen, they will be producing a heat and the light energy. So they will be served as a fuel. What is it? Hydrocarbon plus O2 gives the CO2, that is carbon dioxide plus water vapor plus heat energy and the light. So this is the reaction with hydrocarbons. Next we can see the rusting. So rusting, that is the process of conversion of iron into its hydrated form of oxide. That is in the presence of air and moisture. and that is a humid atmosphere, and that is called as rusting. Rust is the hydrated ferric oxide. Rust is a hydrated ferric oxide. For example, 4Fe plus 3O2 gives the 2Fe2O3, and then next Fe2O2 plus that XH2, X is the number of water molecules which is variable in that, so that it will be giving a Fe2O3 into XH2O. X is the number of water molecules, and then next we can see the uses of oxygen. So it is used in the oxygen acetylene cylinder for cutting and welding the metals. Then it is used to remove the carbon impurities from the steel. Plants and animals use the oxygen from the air for their respiration, and the oxygen is also used in the rocket fuel. It is used for the artificial respiration by scuba divers, mountaineers, astronauts, patients, etc. Then mixed with the powdered charcoal, and it is used as a explosives. It is also used in the synthesis of methanol and the ammonia. So these are about the oxygen uses, and we learnt about the oxygen. Thank you, students.